They feel that carbon will always be carbon, and it will have its half-life, and keep breaking down, but it still be carbon. They don't understand that it unwinds and becomes nitrogen. Nitrogen unwinds and becomes oxygen.
So the periodic table, the conventional use of the periodic table, and what is this other gentleman's name again?
Walter Russell.
Walter Russell. Walter Russell's version of the periodic table. How is Walter Russell's version of the periodic table perceived by people who study this?
Well, now everyone wants to use it. If you can go to in my book, there's a picture of Einstein reading Walter Russell's second book, The Universal One. Because when Walter wrote this in 1926, he sent it out to 300 different universities and physicists. And one of the quotes that Einstein says on his deathbed, I should have spent more time reading Walter Russell's work. That's how, and now they're taking it under their wing. But remember the Michelson-Morley experiment from 1887. They were trying to prove whether there was an ether or an effect of an ether, or the quintessence that everything came from. That used to be called the fifth element, that everything that from antiquity, everyone understood that something doesn't come out of nothing. It's like when you look at the air, it looks clear, but you change the pressure condition. The balance of the change of pressure condition, we call that condensation. It creates clouds. And you change the motion conditions, whether it's moving quickly or slowly, it's going to become snow, it's going to become rain, it's going to become hail. So everything comes down to just one of two forces. Either you're breathing in and filling up something, or you're pouring it out. But the scientists, they ignored Walter Russell's work because he didn't include any equations inside of it. He talked philosophically regarding how things behave in comparison to laying down and following some Newtonian or calculus writing. He said he based things based on, let's explore them naturally. And that's what I did with my book. What Walter Russell was missing, he didn't have the wave conjugations. He didn't have the mirror shapes, the all shapes. And that was because of a mistake that was made 6,000 years ago, maybe. They took the flower of life, which was that symbol. Mm-hmm. If you could go to my book, tcotlc.com, there's an example that I put in there on page 64. And I show the element, the fundamentals. If you could possibly pull that up, Jamie.
What was that .com again? TCLTC?
tcotlc.com. You'll see in there the mistake that they made because they believed in straight lines, because the church was promoting the idea of straight lines. You just tap on right below there. Download. No, just go to the center of the page, and right above that, and you see initial public draft, just tap on it. And if you go to page 64, on the right side of the page, right there, on the left side of the page, you'll see the 5 Platonic solids. Now all of our axioms, all of our postulates have been built off of these things. This is what Euclid went down to Egypt and pulled these things together. Pythagoras worked on them. And these were the undisputed fundamentals of God that he used to build. If you tap onto the flower of life, Platonic solids things, it's going to take you to a video. Turn it, don't have to tap it. But it'll show you the flower of life that they took this from. But you'll see that instead of following the natural curvature of these 64 circles overlapping, they averaged the space where they met. And they invented straight lines.
Why did they do that?
Because they believed that the world was flat. They believed the world was flat at the time. And the church promoted. Pythagorean theorem comes off of this cube, a squared plus b squared equals c squared.
So they wanted to use all of these intertwining circles and create straight lines.
Because that's how they thought everything came down to, straight lines. They thought the world was flat. And I was like, oh my goodness. They didn't open the flower properly. So the next one would be the icosahedron.
Now, the flower of life, it's very, very old. The concept is very old. What was the origin of the concept?
It's the oldest symbol known to mankind. It's believed that it was Anki, the brother of Enlil, if you go by the Emerald
Sumerian
tablets,
text.
the Sumerian text, that was the one that created mankind. Because if you look at mankind, and there's a point I want to make with it. I want you to stay on the book, go back to go to 134 on the book. And this is what that other gentleman being told me to do. He said, why don't you just take the pieces that make up the flower and put them together based on universal ratios. So once you're able to pull it up.
164.
Page 134. 134 in the book. So this is the juxtapose of the mistake they made. Yep, just tap right onto that. Yep, just tap on it. Now, this was made by David Johnson, one of our programmers, Argos Fuel. So if you go to the far left and tap on that, I took 4 of those triangles. And wow. And you can scroll around. This is what happens when 4 bubbles meet. This is the negative space where they can't touch each other. This is hydrogen. And as I was saying, electricity is always trying to get to the center of that triangle, but it gets pushed out. And now you see it has 4 contractive poles, which is the electric poles. Just go around it from horizontally, yeah. It has 4 contractive poles because electricity is seeking a higher pressure condition and forcing it in, where magnetism is seeking a lower pressure condition and spun out. So the vortices, those tips, that's the magnetic field. That's where they begin. But it has an equal attractor and an equal amount of repulsion. So if you go to what happens when 8 bubbles meet, they gave me the patents to that. I called that the tetrahedron.
So this is the negative space in between 8 bubbles.
8 bubbles. This is the negative space where 8 bubbles meet, and you can scroll around.
And this is ignored when they're concentrating on straight lines.
Completely, because if you look from the top, I haven't violated anything. It fits perfectly inside of there. But this is the negative space where 8 bubbles meet, but you'll notice it has 8 contractive poles, but it only has 6 magnetic poles, 6 vortices, so it has a greater electrical potential than a repulsion. So maybe this is the strong nuclear force, and the previous one was the weak nuclear force. So I was like, okay, I called this the Huntian after my son. So I was like, what happens when 6 bubbles meet? If you'll go to the one right in the center. Now you see that it has these huge bubbles, fast moving, but there's 6 strong spheres that's going around this, but the greater attractor has grabbed the 2 weaker attractors. And this looks just like a photon, and guess what? It has 30 poles. What is the speed of light? 299,752,400 something. They rounded off to 300 million kilometers per second squared. But if you look at it from the top, you'll see that I haven't violated anything. This looks like what happens in nature. So I was like, okay, so they gave me the patents to this, but you'll see that there's 6 unaccounted electrical poles to it. So I was like, what happens when 12 bubbles meet if you go to the one right next to it? Another stable structure that we basically see in nature, but there's 4 unaccounted electrical poles to it. 4 spin around it. You can count those 4. You'll see 1 at the bottom and 3 on those sides. This is the basis of crystallization, laws of crystallization that forms. And you can go to the last one. I was like, what happens when 24 bubbles meet? This is the negative space. If you pull to a horizontal on it, this is a negative space where 24 bubbles meet. This is where you cannot distinguish this from the background because all of the electrical potential has been accounted for. This would be the Bose-Einstein condensate, where something becomes indistinguishable from the fabric of space itself, the final state of matter. And the proof of this, the platonic solids, they have a thing called discrete symmetry. You can put the cubes together, maybe you can put the dodecahedrons together, but you can't put all of them together. But you can take the wave conjugations right here, and they